Welcome back to video 2 for AP Physics C, special considerations for our mathematics in Physics C. We have the following chain question here. So assume that this chain started from rest and completely extended, and we hold one end of it up here. Then we let it drop. As it falls, the chain gathers on the bottom here. And at any given moment, it falls a distance x towards the ground. So what we want to find is the total force that the surface pushes on the chain. Well, at any given moment, of course, there is a certain amount of chain on the ground already, so that would be force gravity acting on it. But then there's a force to stop the chain. We'll call that force chain here, force sub c. And therefore, the force of the surface would be equal to the weight of the chain that's on the surface, plus the force that the surface has to push on the chain to stop it. Lambda will be used for this, and what's lambda equal to? It's equal to the mass per length of the chain. I call that the linear density. And that'll be needed because we need a differential expression, dm, as the chain falls through a distance dx. So the force of the surface is going to equal force of gravity plus the force of the chain. And that's just a Newton's third law up here. But what's the force of the chain equal to? Well, the force of the chain is going to equal the change in momentum per time, or the differential dp dt. And what does that equal? Well, the force of the chain then equals dmv over dt. Using the product rule, force of the chain then is equal to dm times v, so the derivative of mass with respect to time, and then we keep velocity constant, plus dv dt, which is derivative velocity with respect to time multiplied by the mass, which those cases held constant. Since we're interested in a dm dt and not dv dt, this is 0. So we're going to be looking at this expression only. The force of the chain is equal to dm dt times v. What would dm equal? Well, dm is going to equal the linear density multiplied by dx. So any amount of the rate of change of mass hitting the floor here is going to be equal to dm, and that has to equal the linear density multiplied by how much of the chain fall at any given instant. In this case, we're considering the differential. And before we do that, let's look at what would happen. What would be the velocity of any of these chain links as they hit the ground? Well, it would be v2 squared equals v1 squared plus 2gx. Since v1 is 0, v2 squared is going to be equal to 2gx. Okay, let's continue with the differential then. Force of the chain equals dmv dt. Well, we're going to substitute in for dm, lambda dx. So force of the chain equals lambda dx dt times velocity. So what's dx dt equal to? Well, dx dt is velocity. So force of the chain is equal to lambda times v squared, because that would be velocity times velocity. Now let's substitute in for lambda. Okay, so force of the chain then is equal to lambda, but what's velocity squared? Well, velocity squared is going to be 2gx. So I'm going to substitute in 2gx then for where I see velocity squared. So now force of the chain is equal to lambda 2gx. Okay, so what's lambda equal to? Well, lambda equals m over L. So force of the chain equals m over L times 2gx. Okay, finally, what's force gravity equal to? Well, force gravity has to equal the mass per length of the chain multiplied by gravity multiplied by how much is actually on the surface. In this case, it would be equal to how much of the chain is actually falling, which will be x. So force of the gravity equals m over L g times x. Adding them together, so we have force of the surface is going to equal force of gravity, which is mgx over L, plus force of the chain, 2gxm over L, and then we get 3mgx over L. So that's a differential way of looking at the falling chain. There's an alternative method looking at impulse. Let's take a look at that. Remember, impulse J does equal m times v2 minus v1. Well, once again, v1 is going to equal 0. v2 is going to equal some velocity. Let's just call it v. So we're going to use the v squared equation equals v1 squared, okay, plus 2ax. And let's just put a little squared on this. Okay, that way we've got that. So v squared equals v1 squared plus 2ax. Okay, so v squared is equal to 2gx. Okay, so there you go. Now again, we're still going to use the lambda equals m over L because dm is equal to lambda dx. Okay, so now that v1 is equal to 0, so if I place a 0 in for this, what does j equal? Well, j is equal to m times v because v1 is equal to 0. But m is a differential, so j is equal to dm times v. But remember, m is equal to lambda dx, so j is equal to lambda dx times v. Okay, but what is impulse equal to? Well, impulse also equals force times time. In this case, force times dt, because time is a differential as well. So we have force dt equals lambda dx times v. Separating variables, let's take unseparating variables this time, I guess. We're going to take dt to the other side. Okay, so force of the chain is equal to lambda dx dt. And of course, what does dx dt equal? That equals velocity. So force of the chain equals lambda v squared. Well, from above, v squared equals 2gx. So force of the chain equals m over L times 2gx. And we see we get the same expression as we did in our last method. And of course, force of the surface equals force gravity plus force centripetal. We're adding mgx over L plus 2mgx over L equals 3mgx over L. So we get the same answer, doing it a little bit different way.